Hi everyone, and welcome to this chapter of Dart Crash Course. In this chapter, we're going to talk about extensions. Now, for those of you who know me from before, and you've seen my posts, for instance, on Twitter and LinkedIn, you know that I'm a huge fan of extensions simply because they make the results very fluid. Like if I add an extension on top of an existing class, then I can actually bring some new functionality to that existing class, or enumeration, for instance, or any type basically. And for some people, this kind of looks magic, but it is a very natural thing to do with existing data. If you have an existing class, for instance, and you want to add functionality to it, you either need to go ahead and create a global function, for instance, that takes an instance of that class. And it doesn't actually have to be a global function. You can put it in some other class that takes an instance of the other class and then produce something new for you, or just perform some work as an async task. Or you could go ahead and add that new functionality on top of your class. Now, this is a distinction that you need to make yourself to understand when is the right time to create an extension on an existing type and when it's the right time to not do that. So these are the things that we're going to discuss in this chapter. Let's go and do what we usually do. Bring up terminal in here and create our application. So we say Dart create with a template of console, and we say extensions like this. And we don't need any external libraries in this example. So let's just say code extensions and then get rid of terminal, and we go into Visual Studio Code and we say zoom level is 6 like we usually do. Get rid of the default file that was created inside the bin folder, and we say example1.dart. Okay, now before we actually get started really doing any work in here, let's get fswatch running as well, example1. All right, so I just wanted to quickly go off the track and explain how kind of extensions work. So let's say that we go ahead and say an extension on int. All right, so now we've created an extension on int. Let's say that, okay, we want to have a getter in here that is called times4, which should take an integer. So if I type in here like final value is 20, now I want to say value multiplied by 4, okay? But I want to have this functionality inside this integer itself. So instead of saying final times 4 like this, I want to be able to say value dot times 4, something like this. Okay, so I kind of want like a getter on this value. So any integer should be able to get multiplied by 4 using this getter. So I say, okay, so I'm creating an extension on integer and I want a getter, and this getter returns an integer, right? So I first go ahead and say, okay, it's an int and it's a getter and it's called times4. What it does is that it multiplies this value by 4. And you can see that this keyword inside an extension returns an instance of that value that you're operating on. So in this case, when I say value times 4, just replace this value with the value of 20. So it will be 20 times 4. If this value was 40, then this would be 40 times 4. Okay, so you get the idea. So I can then go ahead in here and say print times 4. And you can see the results printed to the screen. So this could just be like 30 times 4. You could just call it directly on any integer that you want to. Okay, so this is how kind of integers work. You're adding functionality to an existing type. All right, so let's get rid of this example because this is really not what we wanted to do in the first example. I just wanted to demonstrate the power of extensions and why sometimes we need them. Okay, so for the first example, let's go ahead and create an extension on strings that can basically reverse that string for us. Okay, so given a string of hello, we want to say dot reversed. Okay, and that isn't available by default in Dart, but we can add that. So let's say extension on string. Okay, and we say string, it's because you see, this is I can see when I say dot reverse and it's not a function, then it's a getter. Okay, what should it return? Well, it should return a string. So let's start with that. We say it returns a string and it's a getter. Okay, we call it reversed. And the functionality for it is that we split, and we don't have to have this, we split the string by basically no delimiter in here. So every character will become its own value. So it will be H like this, then it will be E like this, and L, LO, and then we're reversing this array. So it will be O like this. And then we're joining them together with no delimiter. So then it will be ole like this, okay? Like this. So this is what this extension at the moment is doing. And then we can print it to the console if you want to. So we can say print hello world like this and print it to the console. There we go. And that's the result. So you can see this was just a simple example of how you can create a very, very simple extension on a string, which is an existing data type. Let's get rid of example 1 and create example 2. Example 2.dart in here. And then we stop fswatch as well and run fswatch with a main function. All right. So let's get rid of that. Now let's go ahead and create an extension on an iterable of integers. And let's say that actually it could be an iterable of any number and we can sum them up. So let's say if you have the value of 1, 2, 3, you want to be able to say dot sum. Or if you had the values of 2.2, 3.3, and 4.4, dot sum. So what we want is an extension on any number. And numbers in Dart are expressed by a data type called num. So you can type in here num and you can see that. Let's see if we can find it somewhere in here. We ended up here, but it didn't really take us to the right place. Num right here. Okay, so it's an abstract class which int and double both conform to. So what we want is really not an extension on integer, because if we do an extension on integer only, sum is going to work only on an iterable of integers. Actually our extension is going to work on an iterable of num. And we can't do it on an iterable of integer because then it won't work in this case. And we can't do it on an iterable of double because then it won't work on this case. So what we want is to work on an iterable of num. Okay, so let's go and say extension on iterable of num. All right, and this is actually a little bit problematic the way we've written it, and we're gonna have to correct that. So let's say in here that we say, okay, we return num, and it's a getter, and its name is sum. And what does it return? Let's just, for now, let's just say it returns 0.0 or 0 as t. Actually, not t, 0. Okay, so if I go in here and say, okay, final sum of integers, and do that and say final sum of doubles is that. Now, if you hover your mouse over this value, you can see it's a num. And if you hover your mouse over this one, it's a num. That was weird. We kind of were expecting this to be an integer and this to be a double. What happened? Well, the problem is how we've defined our extension. Our extension is an iterable of num, which correctly basically focuses and zooms in our extension on an iterable that contains any type of number. Okay, and in this case, well, we have numbers, and in this case, we also have numbers. So there's really not much problem with how we've zoomed in on the data type. The problem is that we actually don't know what the data type is. We know it's of type num, as some type of an abstract class, but we can't really know whether it's an integer or a double. So what we kind of want to do in here is to say, we know that the data type is of type num, but the return value that we return from here should be of the exact type that we're given. So if it's an iterable of integers, we want to return an integer. If it's an iterable of double, we want to return double. So when we do stuff like this, when we think like this, that, oh, if it's this, then I want to return this. If it's that, I want to return that. When you get into that situation, then you need to basically work with generics. That's how generics solve the problem for us, okay? So let's say, okay, we actually want to work with a generic value in here, but wait a minute, then we broke the contract. Now, Dart doesn't know that this t is actually a number. So the way to solve this is to first give a name to our extension. Let's say sum of iterable. And then in here we say t, but then let's constrain our t to numbers. So let's say t should extend num. This is how you solve that problem. You say, I have an extension called a sum of iterable. It has a generic parameter called t. And then we say we extend iterables of that type that we're constraining ourselves into. And then we say t should be a number. Okay, therefore, in here, you can just say t, we return t. And then you can say as t for now. Okay, and then if you look at the result, you will see it's an integer in this case, and it's a double in this case. All right. So we've solved one problem. So what we need to do in this extension is to perhaps call the reduce function, because we're an iterable. So this is actually an iterable. It's an iterable of number. Okay. So we say we call reduce on it. We get the value of A and the value of B. And then we say A and B should be plus together. And then it should be a T, which is returned from this. Because if you don't do this, then the data types won't match. This will be a number, but in here we're saying we are basically returning T. So let's say as T. And then we can go ahead in here and say we print this guy like this. And then we print this guy as well. Okay, there we go. Let's see the results. And you can see 6 and 9.9 printed to the console correctly. So this sum is an integer and this sum is a double. Okay, so a little bit more complicated example. Let's close example 2 and go to example 3.dart main function. And we go to the terminal and we say example 3 in here as well. And then we can close the terminal. So in here, what we're going to create is, since Dart, unfortunately, unlike Python and many other modern languages like Python, Rust, Swift, all of these languages have the possibility of creating ranges, but Dart still doesn't. And for those of you who know me and watch the rest of the videos in this series, you know that I like to take up these issues because I think it's important for the growth of Dart as a programming language to get these functions in order to be able to compete with most other modern programming languages. I understand that Dart doesn't have to have all the features that other languages have, and it definitely doesn't, believe me, but some of the most important features need to be in Dart in order for Dart to be able to compete with other modern languages. And one of the features that Dart doesn't have at the moment is the ability to create ranges. So for instance, in Swift, you can create a range by simply saying, let my range is 1 to inclusive 3, or you could say 1 to exclusive 3. And you could say in for instance, you could say in Rust, you could say 1 like this. And in Python, you can as well create ranges with some internal functions. So since Dart doesn't have this, sorry, did I say Python? Yeah, it was Python. So in Python, you can also create ranges, but Dart doesn't have that. So what we're going to do is to create a range in Dart as well. So let's go ahead and say we want to basically create ranges of integers. Okay, so what I want to be able to do in this example is to be able to say 1 to 10. All right, and this should give me an iterable. It should return an iterable that is includes 1, 2, 3, 4 like this. Okay, and also I want to be able to say 1 to 10, and I want to say inclusive false. What this means is, should the last digit which you provided in here be included in the iterable? And if it's false, then I generate an iterable that does not include that last value. And the default value of this parameter should be true. Okay, so this is what we want to achieve in this example. So since it's, you can see this to function doesn't exist, we have to create it. But what should we create it on? Well, this data type on the left-hand side is an integer. Okay, and in this example, we're not actually going to create this range on doubles because it would be really strange, like a range from 1.3 to 5.6. What should that include? Should we jump over every one digit, or should we jump over 1.1? Or so it doesn't really make sense in case of doubles. So let's create it on integers. So we say extension on int like this. Then we say that we return an iterable of integer, okay? And we say our function is called to, and we say we need an end, right? This parameter end, which is this value, needs to be passed in here, and it's not a named parameter, it's a positional parameter. Then we say, okay, we also have a named parameter called bool, its type is bool, and we say inclusive, and its default value is true, okay? Then let's go ahead and add our functionality here. So we say, if the end value that is provided to us, if the end is higher than the current value that we're in, so is 10 higher than 1, then we have to create a range that goes up from 1. But you can also use our function to say 10 to 1, and this should create an iterable that goes from 10, 9, 8, 7, blah, blah. So you get the point. So we need to basically check in here, is the incoming value, this end value, higher than the current, this? If it is, then we have to go upwards. Otherwise, we have to go downwards. Okay, so is end higher than this? Let's put this perhaps here. And then we say, okay, in that case, we create a list comprehension. We say for var I, go from this, and I should be less than end. And then we say I plus plus, all right? And then we produce I in here. Also, and this is the fun thing, and we say if inclusive, then produce end as well, all right, at the end of all of this. So this is how list comprehensions work. Otherwise, we say start from, let's see, for, okay, and I should be more than end. So yeah, if basically the range, so if the end is not more than this, meaning that the end is actually less in this case, then we have to start from this value. You can see we're starting from this, and then we're saying that you need to make sure that you're more than the end, so you're more than 1, and then go in the other direction, so go 10, 9, 8, 7, so descending. And if the inclusive parameter was true, at the end include the end value, meaning if inclusive was true in this case, then include 1 in the results, okay? And this is how we've created our extension. So what you can do is to put it to test. Now I've already prepared some examples for this, so I'm just gonna paste them in here so we don't have to type them. So you can see in here we're saying print 1 to 10, all right, 1 to 10, and here actually 1 to 10. And the inclusive parameter by default is true, so 10 is included. Then we say 1 to 10 inclusive false, meaning that don't include the last value, don't include the end value. Then we say 10 to 1, there we go, descending 10 to 1. And we say 10 to 1, but don't include the 1. Okay, it's 10 to 2 then, inclusive. Then we say 10 to 10, just to test a little bit of an edge case, and 10 is included. Then we say 10 to 10, but don't include the 10. So then it's an empty iterable, okay? So it seems like our little extension is working really well, and this is a simple way of creating ranges in Dart. Let's close example 3, and we say example 4 like this, and a main function. Of course, we have to fix fswatch as well in here. Okay, so let's create now an extension on lists or iterables that tells us whether that iterable contains duplicates. Okay, so if I go in here and I say 1, 2, and 3, and 1, I want to have a getter in here that says contains duplicate values. Okay, then I can say, okay, well, it seems like our extension is on any iterable. Like I can here say foo and then bar and then foo contains duplicate values. Okay, so our extension should work on any iterable. So let's say extension on iterable, and we want to say, okay, well, this seems like a getter. It's not a function, right? Because it doesn't have the parenthesis in front of it. So we say, okay, it's a getter and it should return a Boolean value. So let's say bool get contains duplicate values. And how we're gonna fix this is to convert our iterable to a set. So let's say we say toSet, and then after converting it to a set, of course, a set is gonna get rid of all the duplicate values. And we said if the length of our set is not equal to our length, that means that we contain duplicates, right? If the result of removing all duplicates is not equal to the length, if the length of converting, how do I say it? If we first convert this array or iterable to a set by removing all duplicates, and that's what sets do, if that value's length is not equal to our length, that means we definitely had duplicates. So let's print this. I have already prepared some examples, so let me just paste the examples so we don't have to type them by hand, because that's not the exciting part. So 1, 2, 3, it should return false in here because 1, 2, 3 doesn't contain any duplicates. Okay, there we go, false in here. Now we say 1, 2, 3, 1, and you can see it says it contains duplicates. Foo and bar doesn't contain any duplicates, and foo bar lowercase foo doesn't contain duplicates either, because this foo is lowercase. However, if you took this and changed it to say foo bar foo, then the last value should be true, as you can see in here. Okay, really good. So we're done with this example as well. Oops, this is something I do, it seems like once at least in every chapter. Minimize Visual Studio Code instead of creating a new file. So let's say example 5 Dart main, and then we change fswatch to example 5. All right. So now that we have that, let's talk about this example and what we're going to do. So what we need to do in this example is to create an extension on map to find first and then convert values of a given type. Okay, so let's say you have a map in here. How should we create it? Let's say that you have a map, and then we say, let's say name is food, and then we say that we have age. Yeah, age 42. That's fine as well. All right. Now let's say that inside, so let's say final map, and then we want to say final age plus 10. All right. So what we want to do is to given any map, to be able to first find a key, let's say in here. So it's kind of like saying map age. If we can find it, okay, then take this and then convert this value to another value. Or we could say final, for instance, number of digits in age. Then we should be able to say, okay, if map contains an age, then convert it, you can see, to string and then length. So what we want to do in this example is to say, given a key, if that key exists in the map, grab its value, and then let me call a function, and let me provide actually a function to you that can take that value and convert it perhaps to another value. And then I want to get that resulting value. So it's kind of like mapping the value of a key inside a map. All right, so mapping a value in a map, basically, if that key exists. So let's go ahead and say we create an extension on map, okay? And since map contains keys and values, is a generic type, it has a generic key and value, then we say extension, for instance, find, and we say key and value. All right, then we can constrain based on key and value, as I've already explained before. Now, in here, we also want to be able to say that the caller to this function that we're going to create in here called find needs to be able to give us a closure, and in this closure be able to convert the value to another value of another type, for instance. So let's constrain that to a value of type R. So we're going to use this R, okay? So we say our function optionally returns R because we might not be able to find the given key inside the map, and subsequently might not be able to call the closure that is provided by the caller to this function. So we call our function find, okay? Now what we're going to do is to say that, okay, we will give you a value in here of type T, and then using this T, you need to basically convert this to another value of type R. Okay, so let's say first give us the key to look for, and that's key is of type K, right? Because we've constrained our map to keys of this type. And then we say, given this key, we will try to find the value, and we say, okay, then what you need to do is to optionally return this type of R value that you promised in here, and you need to provide us a function, and we will give you the value of this type that you looked for, okay, because you want to constrain to that specific value. And I mean, to be honest with you, this is a little bit complicated to explain because before you've actually seen how it should run. So what I want to do in here is to say, given a key in here named age and a value that is of type integer, because in here you may have like age that is 42.5, but at the call site, what we want to do is to say, give me the value of type, of the key age, as long as it's an integer. And this is why we have this T in here, because the caller should be able to constrain calling this function to a specific data type. Then we say, okay, we will give you that value if we can find it inside this map, and you produce some other value if you want to. And then we will just return that value from this function if we can find that key with that type of value for you. Okay, so it's it's a lot of explanation, but you will see how this works soon. So this is our function call. All right. Now in here, let's go ahead and say first we try to find this value for this key. We say value is this given that key. All right. Then we say if the value is not null and the value is of this type that you asked for, right? Because this is a generic type that you're going to ask for. Then we say, okay, then we return this function, the result of this function that you provided to us. We say value as T. So we give you the value, and you produce a new value, and we return this from this function. Otherwise, we return null. All right. Now, this looks really abstract at the moment, I know, but let's just see some examples and see how this actually works. Okay. So what I'm going to do is to create some JSON in here, and let's say JSON like this. All right. And let's go ahead and start writing an example. So let's say we want to grab the age of this person from this JSON as a string. So we want to convert this age to a string. Okay. So as long as this age is an integer. So let's say final string as age as string. And then we say, okay, take the JSON and find an integer. Okay. And the key, let's put it here. The key to this find, remember the first parameter is the key that we're trying to find. So we say the key should be age. All right. And then the second parameter should be basically your calculation. So it should be saying that, okay, given a key of age with the value that is of type integer, then take that value and convert it to a string and return it from this function. So therefore, even if you remove this, you can see the result will be, actually, it couldn't calculate it properly. It's just because we have to tell the data type in here. Okay. So then we can print this to the console, print age as string. And then if you look at the results, you will see age is 20, but this is a string. Okay, because here we converted it to a string. I mean, you probably thinking, but why are we doing this? Well, this is just an example of how you can use generics on top of extensions in order to basically find a specific value of a given type and convert it to another value. It could be quite useful when you're doing JSON parsing, for instance. Okay, so that was one example. Now, let's take the next example and say, okay, given a name, like here we have name of foobar, produce a string that says hello, that's name. Okay, so let's go ahead and say final, and we say string. Actually, let's say we definitely want to grab a string, and we say, okay, hello name, and we say JSON.find. Then what are we looking for? We're looking for a string, right? And we say find the key of name, and like this, and then given its value, which should be string, which is what we're looking for in here, then produce the value of hello name. And then at the end, convert this and force unwrap it so that it's not an optional. So what we're doing in here is saying we expect the key of name to exist in this JSON. Otherwise, crash the entire application. So this is how you can also use our extension by forcing a specific value to exist inside the map of a specific data type as well. Okay, and I think our examples work even if we remove that from there, because we could go ahead in here and say here you can see, okay, and because if you constrain your closure in here to say it's an int or it's in a string, then Dart says, aha. So this closure, this value in here, this t is an int or a string. Therefore, this t is also an int or a string. So you don't have to type that string or int twice. All right. So let's run this example and see what happens. Hello name. Oh, we are not printing it. Print hello name like this. Okay. Hello foobar. Okay. And another example would be to find, for instance, the address from our JSON and say you live at that address, but we know that the address doesn't exist. All right, so let me just copy paste that example so we don't have to type it again, because it's very similar to what we've already done up there. So you can see we're saying find a key type address, a key named address. Its value should be a string, and as long as the value is a string, say you live at address. And then we say the address is equal to this, but we already know that the address key doesn't exist in the JSON. Therefore, this is going to give us, basically this closure is never going to be called, meaning that the result is going to be null, meaning that we're hitting this wall. All right. So then it will say address is equal to null. So let's have a look in here. There we go. Okay. So this was another, perhaps a little bit more complicated example of using extensions. So let's close that. And then we'll go to example 6, Dart. Oops. And a main function, and let's go ahead and say we're running example 6. All right, so let's close the terminal as well. And what we can do is to create a simple extension on all enumerations. Okay, so let's create a simple enum in here and say animal type. And we say cat, dog, and goldfish, like this, okay? And what we want to do is to have a little property, let's say in here, animal type dot cat, and we want to say name contains uppercase letters. Okay, so what this should return for us in case of cat, it should say, well, the name doesn't contain any uppercase letters, so it should return, so this is a getter, and it should return false. In this case, it should also return false because dog doesn't have any uppercase letters, but goldfish has an uppercase F in here, you can see. Okay, so let's go ahead and say we extend any enumeration like this, and we say bool get name contains uppercase letters, like this, and we'll make it an arrow function kind of, and we say, okay, get the name of this enumeration, okay, sorry, this enum value basically, and we say, does it contain, like this, and then let's go to the next line, and then we create a regular expression. We say reg exp, like this, and we say, okay, a raw string that is a range of uppercase A to uppercase Z. Okay, so let's see how this works. So we can print then this value, and I have some other examples prepared, so let me just place them in here. And this cat doesn't have any uppercase, dog doesn't have, so it should be false, false, true. And you can see the results printed to the console. Okay, so this was just an example of how you can create an extension on any enum. So any enumeration that you have, you will be able to call this this getter on. And let's put a comma in here as well to get the formatting a little bit nicer. Good, we're done with example 6 as well. We're moving past these very fast. Let's go to example 7 and add our main function. And of course, fswatch, which is the usual dance, okay? And we can save this file, good, and get rid of the terminal. Now, what we want to do in this example is to create, actually mix extensions with type definitions. So let's say that you have a function, add, it takes int a and int b, and you want to say return a plus b. And you say in another function that is subtract, and then you subtract these values. Okay, now what we want to do is to be able to call any function that returns an integer and has 2 integer parameters. And what we want to do is to say, okay, call these functions with random integers. Okay, so I should be able to say add call with random values. So this is what I want to do in this example. Okay, and also subtract. So how do we do this? A function on a function? How does that work? Well, as long as you create a type definition for these functions, then you turn them into their own data types. That's magic. So let's define these. Let's say type def int function. It's a function that returns an integer. You can see a function that returns an integer is a function and has 2 integer parameters. So now add and subtract both are of this type. And as soon as you have a data type, then you can extend it. So let's say extension on int function. All right. And then we say, okay, it should return an integer and say call with random values. All right. And let's go ahead and import Dart math. We say import Dart math, and we only show random because that's the only thing that we need from the math package. And then in here, we say final rnd1. So it's the first random number. Okay. And then we get the second random number like this. And then we say return. Okay. And then we call the the current function that we're in, because we can always say this.call, right? This is how Dart allows you to call a function dynamically without its name, because in this context, this refers to that function that we're extending, okay? So we say call with rnd1 and rnd2, and then return this value. Okay, so then we can go ahead in here inside our main function, and you can see now this is all of a sudden working. So I can print its result and print this function's result as well. And you can see we're just getting 71 and 42. All right, and we can add some print statement in here that we actually see the random numbers. Okay, we know the first call is to the add function, so it's adding 12 and 21, so the result is 33, and 99 minus 23 is also 76. Okay, so a little bit more complicated example on extending functions. That was fun. So let's go to example 8 and create our main function, and of course fswatch as well. Example 8, like this. Okay, now in this example we're going to talk about why extension names are needed. Okay, you've seen in other examples, let's say example 2, and in here we had an extension that had a name, and you'd be thinking, does it really need a name? And the answer is no. You can actually remove this name and it still works. Okay, but why do we need the names? And this is what this example is going to demonstrate for us. Why do we need names for extensions? So let's go ahead and create a person class. And I'm not going to write this code myself because it's actually very easy to do. You can see it's a class person with 2 final properties called name and age respectively, and a constant constructor with 2 named parameters called name and age, of course. Then what we want to do is to go ahead and create 2 types of descriptions for this name. One is a short description, for this person. One is a short description and another one is a long description. So let's say extension on person, and let's say string get description. Okay, so the getter is called description, and let's put a comment in here and say short description of a person. Okay, and then we say, okay, the short description should just be $name and $age, like this in parentheses. And then we want to create another extension on person that creates a longer description. So let's say long description on person. So we then take this extension and copy it in here. And okay, then you can see we have a description in here that says $name is $age years old. So name is $age years old. Okay, but how do we call these description getters? So let's go ahead and say we have a person named Jack, and I'm gonna paste the code in here, and then let's say print Jack dot description. All right, now this is the error that we're getting because Dart doesn't understand which description getter we're calling. Even though we have 2 descriptions, but it doesn't know which one. Then let's say, okay, then maybe we should give these names. All right, so let's say we call this short description, and this one we call it long description. All right, now there's another problem. It says a member name description is defined in extensions short and long, and none are more specific. Try using an extension override. And that's the point of this example. In this example, we're going to talk about extension overrides using their names. So how do you call this description? By telling which one you want. And that's when you can actually wrap this inside the name of the extension. So you can say, take the short description, okay, and take Jack in it, and then call description on it. All right, this is a little bit funky, I know. And then we can take the same code and then say long description, and then take Jack inside long description and then call the description getter on it. And you can see then the short description is printed and the long description. So this is called extension overrides using their names. Okay, and that was it, really. That was the last example for this chapter. I hope you enjoyed this chapter and hope to see you in the next one.